So today we'll look at pig, and pig is similar to Hive. Here also you don't have to write any of the MapReduce code. It's pretty interesting scripting language. It's very easy. All you have to do is just remember few keywords. The rest all is pretty common normal English. So the things which were difficult in Hive, those could be easily done in Pig. Some of the things might not be possible in the Pig as they were possible in Hive. So both of the languages have their advantages and disadvantages. Hey Padmani, were you saying something? Okay, yeah, I have not yet shared the screen. So before moving on to Pig, I just wanted to show you one more thing. So I'm just waiting for my server to go up. I'll share the screen once my server is up. So there was one query which Puneet raised offline to me last week. So I think I have not shown you those part. As this class, people do not ask much questions. So I also, sometimes forget to tell you some things. So I'll show you the Ambari UI, how does it look like, and how you can use that Ambari UI. So I'm just waiting for my server to start up, and I'll show you the Ambari UI before moving to the pig part. So what I was saying is, so some of the things are very easy in Pig as compared to Hive. Some of the things would be easy in Hive. So it would be on you to choose the language precisely, what you want to use in your companies, in your production world while you are implementing the things. But both the things would do the same thing. They will trigger the MapReduce code at the backend. They will create a MapReduce code for you. Everything transparent to you. You don't have to worry about those things. All the optimizations are written in the corresponding languages, in the corresponding framework. So everything would be done by the framework. You have to just write the code, which would be not more than 5-10 lines based on your complexity of the ETL. Hey Padmani, I said that I have not yet shared the screen, and I hope you are able to hear me. So what I was saying is, I'm just waiting for my server to come up. I'll show you the Ambari UI before moving on to the pig, and that's the reason I have not yet shared the screen. I'm just waiting for my server to up. So before showing you the pig and then moving on to the pig PPT, I'll quickly walk you through the Ambari UI. So I'm just waiting for the UI to up. Just give me two more minutes. So Ambari is basically used for cluster management. So I've shown you the Hue UI. Hue UI is basically used to interact with the SDFS, trigger your Hive queries from the UI, trigger the pig queries from the UI, or look at the jobs which are running in the cluster and things like that. You can create your Uzi workflows directly from there. I'll show you how to create those Uzi workflows when we're looking at the Uzi session. So Hue UI is basically used for all those things. So I'll share my screen now. It's up and running. So now my screen could be visible to you. If it's not, just do let me know. So this is a Hue UI which I have already shown to you people, and it has all the things. You can write your Hive queries directly over here also if you don't want to go to that black box, and you can trigger it from here. You can just execute. From here you can just drop down and select the database. And if you have to add some jars and things like that, you can add from here. Similarly, so all your query history and related things would be visible over here. And here you can from here you can trigger your pig script. So we will look at the pig in the next few minutes. Edge catalog is basically so now Edge Catalog and Hive are previously they used to be separate projects, but now Edge Catalog is merged with Hive. So all your metadata for the Hive, that is the data about the tables and things like that, is stored in Edge Catalog, and Edge Catalog is used by Hive to basically store all those things, and all the tables which you create would be visible over there inside Edge Catalog. So all the tables which we created in the Hive with Hive, those would be visible to us in different databases. So Edge Catalog is nothing but metadata repository. Am I not audible to everyone, or is just Puneet who can't hear me? Hey, good morning, Shelly. I just saw you.
I can hear you.
Puneet, then it's some problem at your end only again today. Just check your internet connection or something. People are able to hear me. So as just you who can't hear me. So from here you can browse the files as I already told you previously. So this is a UI which I am just walking you through again. And there's a job browser console from where you can browse the jobs which we triggered. So that the jobs which we triggered are visible over here. Right now I have not triggered any jobs, so it's not visible. This is a Uzi UI which will be looking at the Uzi session and so on. So this is a UI which I've already walked you through. Let's look at the Ambari UI, and that would be so Puneet raised this question I think 2-3 days back over the email. So let me show you. So okay, before going to the Ambari UI, you have to go to the UI on the home page, and here ensure that your Ambari is enabled. If enable is if you can see enable over here, just click on the enable, and then the disable would be visible over here. So if your Ambari is not enabled, you will not be able to go to the Ambari UI. Ambari you basically use for the cluster management. So that runs on the port 8080, so 8080 rather than 8000, and press enter. The username is admin, ADMIN, and the password is ADMIN, admin. So if you people want to write it down, you can write it down. I'll ping you on the chat window. The URL is this, and the user and password is admin slash. Everything in small. So here you can view the whole cluster and different things running on the cluster. Basically this is used for cluster management. So all your cluster would be visible over here. I've started 2.2. So you won't be able to see most some of the things which are right now visible on the UI, because I think I've opened the Hotelworks 2.2, although I've shared with you 2.1. If you have 8 GB RAM free on your PC, or at least 6 GB RAM free on your PC, you can use the 2.2 version also. That is again shared on the same shared drive. So there are a few extra things over there. So like Tej is not there in the version which you would be running up 2.1. Zoom, Storm would not be there, Falcon would not be there, HBase would be there. So a few other things would not be there. So basically, what I'm trying to show you people is from here you can maintain, you can do administrator related things which you normally would not be doing up, but I just wanted to give you a glimpse. So from here you can see, I can see the whole cluster dashboard, what is running where, or how much is my hard disk utilized, how many are the data nodes available in a cluster, name nodes, secondary name nodes, memory uses, network uses, CPU uses across the cluster, name node uptime, resource used, and so on. Second is you can look at the different data nodes running in a cluster. So right now the single node machines, I can see only one node, but if there would have been hundreds of nodes, all those nodes will be visible over there, the corresponding IPs and the components running over there. So right now there is a single node, so all the components are running over there only, but these components might be distributed across different nodes like Hive Server 2, things like this would be running on only single node. So whenever you have to connect to Hive to the cluster, you have to connect to a machine where Hive Server 2 is running up. So your Hive Server 2 might not be running on the name node, might not be running on your job tracker node, that might be running on some other node. So that again depend on your cluster management, the admin where they think it should be running up. Similarly, you can look at the jobs also over here. You can add the data nodes over here. You can look at the so this is high availability feature which I've told you in the first class. Security related things. On the dashboard, you can start and stop all the services. So over here, if I say start all, stop all, so I can start all the services, I can stop all the services from here. Or if I have to go to a single service, I can start and stop the single services. So right now I'm looking at the SDFS. So here I can change the configuration related to. So if you are running a say 100 node cluster and you have to change some SDFS related parameters, so one way is you can go to all the 100 data nodes and change the SDFS.conf file on all 100 nodes. Another way is you can open the Ambari UI or the cluster management UI based on the flavors which you are using. So Cloudera has a different UI. On Hotelworks we have Ambari. So Cloudera is all cluster management. So but the UI and everything would remain same, almost same. So here you can just go to the config part and you can look at the different parameters which are configurable and you can change them based on your requirement, name node heap and things like that, replication factor, all those things would be here. So block sizes, everything would be here. Heartbeat interval, port on which it's running up, name node address, replication max. So all the HDFS related parameters would be here, and core site and SDFS site are the two XMLs which contain the configuration related to the cluster. So you can add the properties over here, you can change the properties over here and just click on save. Before that you have to stop the services. Similarly, if you look at MapReduce part, so yarn I have not yet talked about to you people. So we'll look at the yarn part. So MapReduce related properties. So you can see the JVM related properties for MapReduce and things like that would be over here. You can change them from here. And Zookeeper is basically used for cluster management. Pig and Scoop we'll talk about in some time. Falcon is similar to Uzi. So Falcon is basically again a workflow engine which create Uzi jobs for you. This is recently been added to Waterworks. Storm is used for data processing. We will not be talking about Storm. Edgebase is NoSQL on top of HDFS. There is a different execution engine which is said to be 100 times faster as compared to native MapReduce, which has been recently introduced into Hortonworks. So you can stop all these services, you can start all these services directly from here. So Hive will have all the Hive related parameters. HiveSite.xml, the default parameters. If you don't want to go to the Hive console and add the properties over there, you can just add the properties over here. So by that, by the default properties would be set it to your Hive, and those will be executed while your Hive is starting up. So basically, what in short I wanted to show you is all the configuration related things which you want to do on the cluster. All the cluster management things can be done from this UI. Although we are not looking into the admin related things, but it's good for you people to know. Like Puneet was having issues restarting the Hive, so all you have to do is just go over here, stop it and start it. This will stop the Hive and start the Hive rather than going to the command prompt. Or you can restart all the services running on the cluster. Any questions which you have or anywhere which you want me to go into deep dive? Yarn I'll show you once I'll cover the yarn part. If any of the things which you want to look at on the deeper side, but this is all related to admin part. Hi Padmani, you can ping your question over here. Okay, sure. Okay, sure. Oh, sure. So, okay. So I was just showing the different configurations which could be done up. I have not talked about any of the configuration parameters. These all configuration parameters you can look at you can look at them. I'll share if you require. I'll share a book with you. Different parameters talk about different things, but all you have to know is you can come to this UI and change them. And the beauty is if you have 100 node cluster, you don't have to go to the 100 nodes and change those parameters. And you can look at the different quick links over here, like the name node UI. So I can see the name node, its how much it's used, its capacity, and things like that on this UI. You can look at the job browser UIs from directly from here. So this is a resource manager UI. So similar to your job browser, there is a resource manager in the Yarn. I'll talk about the resource manager when I'll talk about Yarn. So next class I'll talk about Yarn. Stage has been recently introduced, and there's execution engine on top. In parallel to MapReduce, and this is said to be 100 times faster as compared to MapReduce. So if you run Hive over Stage, that is said to be 100 times faster, and that is claimed by these people. So Zookeeper is basically used for cluster management. Gange and Nengyos are again used for cluster monitoring. Here is the edge-based related configuration. Edge-based might not be started up right now. So let's so this is a UI which you can just have a look over here and just browse through this. If you have any specific queries, do let me know. Okay, so let's move on to the pig part. So before that, any questions from anyone? Sally, you joined late. Do you have any questions on the Hive assignment? Were you able to do it? Anything on that part? Okay, sure. So I assume you people were able to do it. If not, do let me know if you can discuss them in the class or after the class. But please try to do that Hive exercise. That would be, much beneficial for you, because if you are dealing with a big data related word, you definitely would be writing Hive queries. Okay. So as I already told you, Pig is again similar to Hive, but it's a scripting language. Hive was a SQL kind of language. Pig was started as a project in Yahoo, and 30% of Yahoo jobs are running on Pig. The problem with the MapReduce word, as you know, already know that you have to write a complex Java code, maintain that, create jar, push that jar to the Hadoop cluster, and things like that. So to remove that complexity, they created Pig. It support most of the things which could be done by MapReduce and which could be done by Hive. I won't say it's similar to Hive, but there's a drastic difference between Pig and Hive. So the problem with if you have to write joins or splits or kind of these chains, it's pretty complicated in MapReduce world. For pretty commonly used operators like join, projection, aggregation, sorting, distinct, all these things you have to write extensive code in MapReduce world. So overcome these problems, Yahoo people created a language called Pig, and all these things, as they were pretty easy to write in Hive. Similarly, it's pretty easy to write in Pig also. So you don't have to worry about the complex semantics of MapReduce word. You have to write simple code, and it could be pretty easily done in Pig. So before going on to the syntax of the language, I'll show you two examples. In both the examples, I just wanted to give you the feel how easy it is to write a scripting language like Pig. It's almost normal, simple English, but few of the things you have to remember for the syntaxes. So in the two examples which I'll be showing you into next 4-5 slides, I just want you to look at how easy it is. Don't worry about the different syntaxes, but let's look at how easy it is to write your problem statements in Pig. So as compared to Hive, you would be using Pig if your data is unstructured, and if you have to create chains like this. So able to create chains like this, one MapReduce output to another to another, things like that. In those scenarios, Pig is very useful. So let's look at a generic problem statement. The problem statement is I have to find out top 10 most visited pages in each category. And category is nothing but the URL. So this is a clickstream data collected from some websites, and there are two files which we'll be looking at. One file is visit file, another file is URL file. So visit files talks about the visit by a user to a particular website and at what time the visit was. Only three parameters for the simplicity of the problem. So that could just contain the user ID and the URL which user visited and what time he visited. The second file is URL. That is a metadata about the URL. So the URL and the category to which URL belongs. So CNN belongs to news, BBC belongs to news, Flickr belongs to photos, and so on. So these are two files which we are looking at, and our problem statement is pretty simple. Find out top 10 most visited pages in each category. So for each category, we have to figure out top 10 most visited pages. So if you have to solve this problem, and if you have to create a data flow for this problem, sorry Padmini, I'm not able to get a question. Can you please
What page rank it is?
so yeah, it has page rank also, but we are not looking at a page rank right now. Our problem statement just want to look at top 10 most visited pages, that's all.
Okay.
So although that is there in the data, but we'll ignore that part. So we are not worried about the time part. Also, we are not worried about the page rank part. We'll ignore these two parameters of the data, attributes of the data basically. So if you have to find out the top 10 most visited pages in each category, so what are the top 10 visited pages in each of these categories, distinct categories. So what we have to do is we have to load the visits file, that is this file. Then we have to group by URL. So we'll group this file by URL. Then we have to, for each URL we'll generate a count. Then we'll load the another file, that is this URL file, and join both these files based on URL. Now we have the URL count and the URL related category from the separate file. We'll group these by category, and we can just dump out the top URLs for each category. Alright, there's a normal data flow diagram, or algorithm, or the flow which you will create, a flow chart which you will create for solving this problem. So now let's look at how I will write my syntax in pig language to resolve the same problem. We'll again look at this data flow diagram. So we can do this by pig or by MapReduce or by Hive. It's all our convenience what we want to use up. But let's look at the pig part. So I'll browse to this data flow again and again. So first we were doing is load visits. That is, we were loading the first file. Then we grouped this file by URL, and then we generated the count for each URL. So let's look at the pig script. Load, that is a file. I have loaded the visits file and assigned it to a variable called visits. I have grouped this variable visits based on URL. I have generated the count of each URL in this visits file. So for each visits, generate URL and the count of each visits. So these were the three lines in my data flow diagram. After that, I loaded the URL file and joined both the files based on the URL. So I loaded the URL file. So the file is URL info. This is assigned to a variable called URL info. I've joined both these things, joined visit counts, that is this file which has the count of URLs, and this file URL info. So join this and this based on URL. This is the thing which I was doing in the data flow diagram till here. And after that, I'll just group this output by category and dump top 10. So after this, I have just grouped it by category. So group this visit counts by category and generate top 10 counts and dump them. So 1, 2, 3, 4, 5, 6, 7, 8 lines of big code, all that thing is done for you. And 8 lines in my data flow diagram also. So each step in the data flow diagram, there's a corresponding step in the pig, and I can do or achieve the output of this problem pretty easily. So let's look at this pig script again. So what I did is I loaded the visit, the first file visits, grouped that by URL. So group is a keyword. So over here we'll look at those things. We loaded the things. So these are the operators in the pig to interact over files. So load and store are the operators to interact over files. Then these are the optional parameters, but these are the semantics which we define over the file. So we tell how our file looks like we did in when we created the tables on Hive. So if I have to create the table on this file, I have to define what are different columns of the file. Similarly, by this way you can define in Pig. So here we are defining a schema on the file. This is optional. I'll talk about next few slides. And this gives extensive power to Pig by making this schema optional. We'll look at that part in some time. So I would have written this statement like this also. This is not required. I would have written this statement just like load visits. And in this case, schema would be generated on the fly based on the operation which user is doing on the file. How that is done, we'll talk about that thing in some time. Then these are some user-defined functions. So as I talked in Hive, we created a user-defined function. Similarly, over here also you can define user-defined, or you can basically create UDFs, user-defined functions. So this top is a user-defined function which is created and we are using it. So, and this join is a join operation, group is a group operation. So all these are operations for each, all of these are operations which we can done on the variables which are initiated on the files. So we'll look at all these operators in detail in some time, but I just wanted you people to get a glimpse of how easy it is for us to create a data flow in Pig. Any questions? Anything which you want to ask over here? No. Okay. So this is extensive MapReduce code which you would have written at the backend to achieve this problem statement. So at the backend, what the script will do is it will create a MapReduce code for you. That's definitely short. So this, but you don't have to worry about that part. That will be done transparently to you. You will not even be aware of that. But let's look at the MapReduce code or the different jobs which would be triggered at the backend. So you see, your first mapper would be created up to load the file. Second mapper would be and the corresponding reducer would be created up to generate the count of the URL. Second MapReduce code which will trigger up, which will loading your URL file, and the reducer phase will be joining these two files. And the third MapReduce will be triggered up, which will doing the group by based on category and the dumping the output on the reducer phase. So 3 MapReduce codes which you would have written up to achieve this problem statement, but with the help of Pig, you have achieved this by writing 7 or 8 lines of code. So basically, it has made your life extensively simple, and all you have to do is just remember a few of the syntaxes of the language. So these are the 3 jobs which would be triggered up in sequence for you. You don't have to worry about those jobs. So let's look at a similar problem again. This will give you a deeper insight of the language, and we'll try to run one of them, and then we will proceed up to look at the syntaxes of the language. So again, here I have a similar problem statement. I have file called okay. So I have a file which contains a user-related data and another file which contains the pages. Again, again a similar stream data. One file has the users and their corresponding ages. So that is user-related data. Another file has the pages which are visited by different users. So this clickstream data contains the URL as well as the user ID. That is the user who has created, who has visited the corresponding URL. So user file will have the user related parameters like user age, name, and user ID and similar things. Pages file will have the URL and the user ID was visited and some other data. So for the simplicity of the problem, will only look at the attributes which are relevant to our problem statement. So the problem statement is we need to find out top 5 most visited pages by users between who are aged between 18 to 25. So I have to figure out pages which are visited or which are frequently visited by users between age group of 18 to 25. So if we look at this problem and if we draw the data flow diagram for this problem statement, what I have to do is I have to load the users file. I have to filter the users between age to 25 from 18 to 25. Then I'll join the user IDs which are in between this age group with the clickstream data which I have. And now I have only the page data for these users. So what I can do is I can group them by URL. I can generate the count of the clicks and I can just dump the top 5 pages. Right? Almost similar to the previous one, but I just wanted to show you one more example. So on the pick, what we'll do is for each statement, load. So load operator, I'll use the load operator of the pick, load the file. There's an operator called filter, filter this user's data, load the pages data, join them by the join operator, group them by the group operator of the pick, count the clicks by the count operator of the pick, or the count UDF of the pick, order the clicks by order operator, limit top 5 and dump them. So for each step, there is a similar operator how we use in the previous example. Over here, load group for each, load join group for each, and store. So similar to this, for this data flow, we have the operators. So and these are the 3 different jobs which will trigger at the backend for you. So 3 different jobs, MapReduce code which will trigger for you by these operators. So first one would be triggered till this level, second up for this, and third one for this. So this is how your pick code will look like. Load your users data, filter them between this age. Yes, pick. Oh, sorry. Yes, Puneet. One MapReduce code is equivalent to your one job. So our job will always have mapper and reducer code. There might be cases you don't want reducer, but in that there could be a MapReduce. That is the extreme case, but in a normal scenario, one job is equivalent to a MapReduce code, one MapReduce code. So we are filtering the users, that is this user, by age. Then we are loading another file, that is pages. So loading pages. Then we are joining that both the dataset pages and user and the filtered users. So pages and the filtered user, we are joining them based on the user ID. So filtered and the pages, we are joining them based on the user ID. So the user and the name, so that this is ID in this file and this is ID in this file. And then group them based on the URL. Then for each group, we are generating the count of the clicks. We are ordering them based on the click counts and limiting top 5 records and dumping them. Any questions, any queries on this part? We'll just run this in a minute. No questions? Okay. So let's try to run one of them. So let's okay. Let's first go to the UI and let's look at the data. So this is the pages. So we have the user ID and the page which he or she visited. So the we visited google.com, Pratik visited google.com, Neha visited designpathshala.com, and so on. So this is a clickstream data, only two parameters which are relevant to only two attributes basically, which are relevant to our problem statement. And this is the user's data. So the user ID, that is the user over there, and the corresponding age. So Naveen is of age 32, Pratik is of 19, and so on. So two files, user ID and the age, and here, so here the username is basically user ID, and here the user ID and the corresponding page which he or she visited. So let's try to run that pig statement. So, so similar to Hive, you can run the pig. So similar to Hive, you can run the pig statement also in three fashion. One is just type pig and press enter. This will take you to the pig console. Or you can say pig minus Hive, pig minus f, and give the file directly. Or you minus c. So similar to Hive, you can run the pig queries in the same fashion. So let's go to the pig console and we'll run this. So this is a statement which will run. Okay. So let's go to the pig console and we'll try to run this one by one. So first remove the output file. And now let's load the user file. Yeah, this was CSV. So the file was CSV, so we have used something called pig storage. I'll talk about this part. So here I'm telling pig to read my file as a comma separated file. If I have not used this, by default people will assume my data is tab separated. So now I'll filter the ages. So filter the ages. Now I'll fill.
Repeat that last bit. Can you repeat that last bit that you said with the using the pig storage with the comma?
So if you look at the file, this is comma separated data.
Right.
So by default, as I told you previously, all of these technologies, think of that your keys and values or the data is by default tab separated. But this data was comma separated. So we have explicitly told pig that my data is comma separated, and by the help of this pig storage thing.
Okay, thank you.
So now let's look at the page data. So the page data, filter the data. Join both the data sets. Group by URL. For each group, generate the counts. Sort the data. Find out top 5. Now dump it. So till now you can see all the commands which are running up were basically running too fast. So practically till now nothing has been run. Nothing. It's just the compilation part which pig is doing. So till we don't use something like store or dump. So dump is similar to store. We'll talk about all these things in some time. So till we don't use dump or store, pig will never process your data. Data processing happens once you give command like dump or store. So now it will do the real processing for you. So till now it was just doing compilation of your code which we were telling Pig to do. Once we give real store or dump, that time only your the real data would be loaded onto the file and your map reduce job will trigger up. So you can see your first job is triggered. So it will trigger your job, will do the processing and will store your output at the location which you have given, which was this location. So by the time it's running up, any questions, anyone else?
So do you typically run it from the command line, or do people run it from the GUI?
Okay.
Do you have files that are your pig files? So what's common practice?
So you can trigger it from here also. So the common practice is basically when you are running your so basically there are two phases in your running thing. One is the development phase, one is your implementation phase, or one is your daily ETL phase or a production phase. So when you are doing a development, I never use UI. I am not a UI person, but you can use the UI. Or practically, you would be running them from the file. Once you are basically there are three phases over here. Basically. Before that, one phase is while I'm doing a development of the script. While I'm doing the development of the script, creating a file is not possible because I have not written all the 10 commands. So at that time, you will be using this pig console because running one by one command, looking at the output is pretty easy over here. That can't be achieved on the file. Once your code is final, you would be triggering it with the help of pig minus f to look at the final outputs, or basically look at some sample data. Once this is done, you would be configuring these files onto the UDI workflow, which will be driving up these things on a daily basis or on predefined frequencies for you to do the ETL on your cluster.
Okay, thank you.
Type. So please, what is the question? What do you mean by type? Question mark.
So what I mean is that
output. So you know the answer.
Output.
You know the answer. What is the default? Because in the store we have not. Yeah, in the store you can see I have not given anything to it. Sorry. Over here I have not given anything, so it will be by default tab separated. So it will take some time. It will trigger three jobs. Two I think are triggered up. This is the second one or third one I think. So now you can see on the job UI you will be able to see them. Job browser. See job. Okay, so this is the third one which is running up right. So from here you can track the things. And
there is one more thing.
Yeah.
This .pig logic which you have run, so that thing has to be written on the local file system, right, or in the HDFS only?
Local.
That file.
That is local file. Yeah. Okay. So all is same thing applies everywhere. You send your ZAR from your local to your task job tracker. So your jar would be created by the pig. So you tell pig from your locally from the Unix cluster only. So it would take some more time. So we'll look at the output in some time by the time it's available. So let's look at the different data types available over here, different operations which we can do with the help of this scripting language. Okay, so these are the few important things which you should be knowing up. It's not cyclic, so you can't create cycles like thing, loop kind of things in this language. There are no if and else, so again you can't write if and else kind of things. Basically, it's widely used for data pipelining, as you can see in the previous examples, where we were doing data pipelines. So it's normally used for data pipelines only. And Hive is mostly used for structured data. Pig you can use for unstructured data, and Pig is very useful if your data is unstructured as compared to Hive. So data flow language, I just show you various. It supports various data types. It supports your dynamic schemas. How dynamic? I'll just tell you in next slide. It supports UDFs, user defined functions. We have used top function in the previous slides. So what's the philosophy of it calling pig? The name is pretty interesting, pig. So there's a philosophy which Yao says they think of while calling it pig. So pig can eat anything. Similar to that, pig as this language can eat your any kind of data, be it structured data, be it unstructured data, be it relational. It can eat or it can process basically any kind of data. Pig can live anywhere. It loves to live in dirty places. Similarly, the pig as this framework loves, or you can basically lives or loves to process your untidy data, which is highly powerful, and it's parallel framework, so it can process your untidy data or unstructured data very fast. Pig is a domestic animal and can be tamed up. Similarly, pig as this language could be very easily tamed up by you people. You have to just remember these few. Just a minute, I'll read your query. So as you can basically, very easily tame the whole data workflow cycle. And pig fly is a saying which means you can do anything. And similarly, pig as this framework can do anything on your data. What could be done by MapReduce part. So yeah, Puneet, we'll be looking at all these things. Just wait for this session to end up. We will be looking at all these things. So this data would have been processed by now. Yeah. So it's processed. Let's look at the output. What was the output path which I gave? So see, files, tabs updated, the top visited file, design Pathshala 9 times, Google 4 times, Gmail 1 time, and so on. So top 5 pages printed over here, by default tabs updated. So these are the data types supported by the language. All these are self-explanatory. Anyone want to explain me anything? Char arrays, array of characters, byte array, date time. So these are the complex ones. Tuple is a set of fields. As you can see on the right hand side is an example part. So 19,20 is a tuple. Tag is a collection of tuples. And map is nothing, key and value pair. So tuple and the bag are new two things over here for you people. I'll just repeat again. Tuple is a set of fields. So as you can see, 19,20 are two fields. So this is a set of two things. There could have been 100 things over here. So tuple is nothing but a set of ordered fields. And collection is nothing. Bag is nothing but a collection of tuples. So these are the brackets which are used to denote these things. So tuple is normally denoted by these brackets, and bag is normally denoted by these curly brackets. And map is denoted by these square brackets, and key and value pair of a map are separated by hash. So these are the default denotations of pig for these complex data types. I'll show you some examples of these complex data types also. So if of any of these things I forget to tell you by the end of this session, to remind me. Okay, so nested data model. So this is a nested data model, which is a collection of You can see a couple of basically this is your one bag, and this is a different thing which you are creating over here. So basically, you can create nested things of the tuples, bag lists, and the kind of things. I'll show you some examples. So now let's look at the different operators, and we'll slowly look at these things, the complex data types also, and different operators which we have discussed, and in our different examples. So if you remember over here, all of our statements were assigned to some operators. So each line in our program is a statement. Each line in your program is a statement, and each statement is always assigned to some variable, and that variable is later on used to denote the output of the previous statement, of the statement to which was assigned to that variable. There is no limit how many statements you want to assign or you want to basically write up. It's all up to you. Pig will create a data flow data workflow for you. There's no limit on the number of statements which you want to write. So each line is basically called a statement, and each statement is always assigned to some variable. Schema. So this is a very interesting thing, and this, if you understand this thing, you will be able to understand why I was saying it is used to for unstructured data, or your data has no structure, or you want to basically on the fly figure out the structure of the data. So schema part is optional over here. How that is optional? User can optionally define the schema. Once the schema of the source data is given, all your schema is basically inferred from that. So what do I mean? What I mean by inferred from that? So here you can see I have given that my users file will have two columns. First one is name and second one is age, and the name is of type char array and the age is of type int. So the schema of this file is defined in this statement. Rest of the statement will infer the schema of these variables based on the operation which I am doing on the user's variable. So here I say age is greater than 18 and less than 25. So because age was of type int, and so basically the different variables which will be generated out of this users would be inferred automatically from the operation which I am doing on the users. So if I have defined some UDF over here which is doing summing kind of thing, or doing string operations, automatically the output of those things will be inferred by the pig. So why schema? So if the schema is optional, do you think you should be defining a schema? It's all up to you, but if you define a schema, it's pretty easy for you to maintain the code, read the code, and later on, refer the different columns in your file. So, but again, it's up to you. Now, if you define it, it's good. Pig will use that. If you don't define it, Pig has the ways to infer that. How? We'll just look into the next slide. So here you can see I have three statements reading the same file: input, and in the last statement I have not even defined the schema for the file. In the first two statements I have although I have defined the schema for the file, but I have defined different attributes for the schema. So here you can see I have said file has two columns. One is name, second one is age. Here I am saying age is of type int. Here I am saying age is of type char array. And here I am not even telling how many columns are there in the file. And all the three lines I am reading the same file, that is input/a. How Pig will interpret that? If I am loading this file and assigning that to variable a, and if I want to say do some operation on the age as a parameter, so I have to filter out the age which are not basically filter out the data from this file for the ages which are not equivalent to 20. So if I have defined the schema, I can just say age not equals to 20, and Pig will do for me. If I have defined age as a char array, so this char array is always easy, because in that case, even if it's int or anything, I can that is always be assigned to char array. So I've just for simplicity I've defined as a char array. So if I've defined as a char array, all I have to do is just change the parameter. Here I've just given 2 quotes. So I'm giving 20 as a character comparison to this age, and pick will do rest. That's the rest of things for me. And here I have not even told pick how many columns are there in my file. I can refer the columns by $0, $1, and so on. So first column is $0, second column is $1, and so on. So I'm referring to the second column by $1, and I'm saying it 20. So I am telling pig that my second column is of basically I want to do some operation on my second column, and I have to filter out the values from second column of type 20. So pig will cast the second column to char array because I am giving 20 as a character over here, and will do the filtering for me. Let's try to run it, and in the next example we'll be using some other complex things, and that will make it more clear to you. But let's try to first run this example. So I'll go to the pig console only. So I've loaded the file with the schema. So you can see I've given the schema. So now if I say, so describe is a way to look at the variable. Describe A. So it says A has 2 columns, name and age of type int. Now I say filter, and if I say dump, so dump is basically used to dump on the console. So it just dump on the console rather than on the file. So dump you will be normally using up at your development phase where you are doing some debugging. So if I say dump A, it will do the processing and will dump the ages which are not equivalent to 20 from this file. And now we'll try to load without the so I'm using the pig storage because that file was comma separated. So this is the same users file which I've used previously also. So by the time it's running up, we'll try to load. So you can use the same variable again and again. If I run this now, the previous one will be overloaded. So let it run, then I'll use that. So just give it a minute to run. So you can see all the ages are here except 20. 20s are filtered out. Japanese is dump, DMP. So it's jumped on the screen rather than storing onto the file. If we want to store it to the file, we use store and just give the path where we want to store. So let's try to load the same file without giving any schema. So now you can see it gave me a warning. It's trying to implicitly cast it to char arrays. So pig just try to cast it to char arrays. Now based on the operation, it will assume the parameter. So now if I say define A, describe A. The schema for A is unknown. Pig do not know the schema of the A because I have not given the schema. But even if the schema is unknown, I can do the operations. I just said second column of this file filter by 20. And if I say dump B, it will do the same thing. Makes sense how schema is. So now if you would have really ran the hive problem statement, there the table had a lot of columns, and you have to create all those columns. If you run the same thing over here, you don't have to define the schema. All you have to just say $5 or $6, the column which was used for the grouping part, and it's pretty easy for you. So that's the reason it's highly used for unstructured data. You don't have to define the structure or anything. All you have to just use the column on which you want to do the operation, and the schema of the or the type of the column would be decided based on the operation which you are doing on the column. Let's look at one more example by the time just running up. So
I have a quick question.
yeah.
So is there any reason why you wouldn't want to define a schema? Are there use cases that you would not want to, or?
Okay, sure. So when your data is coming totally unstructured or semi-structured, basically, 1 minute. Puneet, just give me a minute. So first thing is for the easiness. Second thing is for the if you are not aware of what is the kind of data which you have. So if say your file is coming up where there are hundreds of columns, the columns from 1 to 10 always change up. You are not aware of them, how they come up based on the different operations which user is doing on the file or based on the input stream and things like that. When I'm processing the data, all I'm worried is columns from say 11 to 15. And rest again, other columns are again changing up, or these are not time. I don't know what are those columns. So in such a scenario, I will not define the schema on the file. I'll just use $10 to $14, and I'll do the operation on my data. Or if the records are changing up, okay. Before that, just look at this example. Look at this example, and I'll answer your question after looking into this example. So. Okay, so I'll not read this file. Let's look at this example. So after this example, your question to your answer would be, you will able to get few more pointers to the answer. So here what I'm doing is I am loading one file that is NYSC daily, and NYSC daily. Okay, so let's look at this NYSC daily file before. So this file has these columns: the stock, the exchange, the stock name, the traded date, the open value, close value, average traded value, total volume, and end of the day value kind of things. So what I'm doing is I have just loaded this file. I have not given any schema for this file. Now let's look at the beauty of what pig does is. So some question I think someone has asked, character only. Puneet, after this example, I'll come to your question, and you basically will get the answer. So what I say is $7 divided by 1000. So basically what pig does is, based on the operation which I'm doing on the file, pig just tries to assume or safely guess what is the data type of this column. Just based on the operation which I'm doing on the column, pig tries to figure out or basically find out what would be the data type of that column. I'd always try to play safe. So on the 8th column, that is $7, it starts from $0. So $7 is the 8th column. I am saying $7 divided by 1000. So as I'm doing a division by 1000, it assumes the 8th column is integer. It will assume 8th column is an integer, and the output of this column would be integer. We'll just try to do this in some manner. On the 4th column, I am saying into 100.0. So when I'm saying 100.0, it assumes the 4th column is double, and will do the operation, and will basically cast the 4th column to double, and will do the operation on the double. On $0, that is the first column, I am doing some string operation, so it will assume my first column is string, and it will do the operation. And this is a complex case. So here I'm saying $6 minus $3. That is, I'm subtracting 7th column from the 4th column. So here again Pig tries to play safe. So first it will try to assume everything is a char array. Sorry, a byte array. So by default it starts from the byte array. Byte array can store everything. It's just byte 0s and 1. So by default it starts from the byte array and then try to play safe. So first, so based on the operation minus, this minus operation can be added or basically applied on either double, float, long or int, right? So it will just try to play safe over here, and it will, what will do is it will assume this as the doubles, because double can store your other things. So you can see double is of type 64 bits, so it can store your float also, it can store your long also, it can store your int also. So here it will try to play safe and it will assume this thing as a double rather than float. So that is what I was saying, it will always try to play safe and will try to assume the data type of the column to the safest assumption based on the operation which you are doing on the column. Now, to answer Shelly your question, if while converting these two doubles, it is so as there is some faulty data type or for some faulty rows where the seventh column has some characters, so Pig will just convert them to null and it will process your further rows. So it will not give an error, not give anything, but it will just output this thing as a null for that particular row. So this is where your beauty comes up in not defining the schema. So even if your data is unstructured, your data is coming in such a format that you don't know what to do with the structure of the data. You're just applying the operations on your data, and even if some faulty rows are there or some faulty data is there, Pig will handle that thing by the beauty of the language. So does this answer your Puneet your question and Sally your question? Does this make sense?
Yes, thank you.
Okay, so let's try to run it. So let's try to load this daily file. So I've loaded this daily file, and now we'll do some operation on the scales. So you can see it's giving an implicit car. So now see, casted to int, double, char array, and so on. And if I say dump, what was the parameter name? Else. For the last one, I just said using overload function. We'll cast it to double based on the overload function. So again, it will take some time to run up. So we can look at the output once it comes up. But any other questions? Anyone else? So if I have to load this file into Hive, you can see I have to create a column data type or table basically on this file and then run the query. But in Pig, I just wrote one line, load this file, rest all is done. Now I can just do the operations on this file. Now I can just easily do the operation on this file. So I have to write less code, and I am not worried about if there's some issues with my data or what's the data type of other column which I am not aware of. So the
So
pig,
would common practice be that you would develop your pig scripts and then you would just have a script that runs them, or how would it? Once you
yeah,
have your scripts set up, do you then have like a shell script that would typically run them, or what would happen at that
okay.
point?
Okay. So basically, we will look at the Uzi. So Uzi is a workflow engine. So on the
Oh, okay.
you can just stitch those things into the XML kind of language Uzi, and Uzi will trigger them based on the predefined frequencies.
Okay, thanks.
So see the output. Last column is assumed as your double, and so on. So pig will try to cast the data types when meet type is so warning would be thrown up. We have seen. It will not throw you validation issues. It will not throw an error if it's not able to typecast to the corresponding data type. It will just convert that to null. Basically, for the corrupted records, it will basically convert them to null and will output null. So to give you an example, let's say this is the data which I am loading up. I say load, so this is the year. This is the temperature recorded for at a given point of time and that year, and this is the quality of this temperature which is recorded up. So I am saying the year as char array, temperature as int, and quality as int. Now you can see there is one faulty record over here. So when I've loaded this file, I say dump records. You can see this is missing. So this is converted to null. So pig will not give you an error. It will not throw you anything. It will just by default, basically silently convert that thing to null and will do the rest of the processing for you. So same thing happens when it assumes the data type based on the operation. It will just convert that to null and it will silently do the processing for other things. It will not throw any errors to you. Right, so figure out corrupt records. Pretty simple. You can just filter out the nulls and that will give you the corrupt records. Okay, one thing very important, just remember it, when you will run your first pig code, you definitely will face this issue. So the keywords are basically case insensitive. So load can be written like this load, but fields or which you create, the field names which you give, the parameters which basically the fields which you create which are assigned to the statements, these are case sensitive. So this a load something is not equivalent to a is equal to load food. These are case sensitive. This is a common mistake which people do, and they just waste hours and hours when they first on their first pig program. And similarly UDF. So if you create any UDF or if you are using your function which are defined in pig, so the count is not equivalent to this count. Most of the UDF which are defined in pig, so there is something called piggybank.jar which is already there in your clusters. So this by default comes with pig. That has hundreds of pig normally used functions. Most of those are in upper cases. So remember to use them in upper cases. If you try to write it something like this, those will not work. So the keywords are case insensitive, but the fields and the UDFs are case sensitive. So remember that. Comments. So these are different ways you can comment the code // dash. You can give it like this or multi-line. So similar to your Java thing. Pig functions. So we have looked at these functions somehow, but let's look at them in detail. So eval, filter, comparison. So these are the different categories in which you can segregate your different functions. So eval, we filter, comparison of two things, load and store. So these are on the operations on the file. These are on the data. The upper ones are on the data. UDFs, you can create your own UDFs. There are a lot of UDFs in piggybank.jar which I've shown you in the previous slide. So I'll show you all these things. So let's look at these functions one by one in detail. Store. So we've already run it into the previous command. So store is nothing but to store your data onto a file. So store your variable name into the file, or if I say using pig storage, then I can just say comma. So if this is a CSV file which will be created to you've created for you, that is comma separated file. You can define anything else. If you want your data to be hash separated, you can just say hash, or if you don't give it, by default your data would be tab separated. So you can use pig storage as and when required. So stores your data to some file. Just dump your data onto the console, like we did in the previous example. We just say dump and your variable name. So dump your process variable name, that will dump onto your screen. Operations: load, store, filter, join, generate. Let's look at some of those examples. So store a into out the file name using pig storage : so my data is stored at this file. If I say get this file, there's the data which is there in the file. Now if I say dump a, so these are two different variables. Again, so this was data was stored as colon separated. So we just look at this data. Now let's look at some other data. So A has this data, Joe, Cherry, 2, and B has this data. Sorry. So A has this data, Joe, Cherry, 2, Ali, Apple, 3, and so on. I have generated B from A, where I'm saying generate for each A. So for each is an operator which will run on each row of A. So for each is an operator which will run on each row of A. So what I am saying, for each A. So for each row of A, generate. So for each and generate are used simultaneously. For each A, generate $0, that is the first column of A. So this column, $2 plus 1, that is the third column, and sum that with 1, and the constant, that is nothing, a constant string. So if I say dump B, something like this will be generated. First column, $2 plus 1, so 2 plus 1, 3, 3 plus 1, 4, and so on, and the constant. So for each is basically used to run on each row of your input, and generate is the keyword used for each. Now let's look at some other data types. So I say this is my A. I'll clear the screen. So this is my A. This is my A, and this is my B. Now what I say is C join A by $0 and B by $1. So use first column of A in the joining and the second column of B in the joining. So first column of A in the joining is 2431, and the second column of B in the joining is 24032. So based on these keys, it will be joined. So this will be inner join A by $0, B by $1. So you can see the joining parameters will only be available. So 2 will join with this 2, and there were 2 2s, so 2 goes for 2, 3, and there was no 1 over here. So this is not there in the output, and similarly 0 was not there in the A, so that is again not there in the output. So this is the inner join. We can do the left outer and the right outer. I'll show you in some time. Oh. So these are the useful operators for you when you're running your code and you're basically doing the debugging on your code. These are pretty useful for you. This time I've just shown you, but explain and illustrator are also again very useful. In Hive, I have not told you the explain variable. So explain is there in Hive also. So if you have written some query, or basically, if you remember the MySQL word or the Oracle word, you can look at the execution plan of the query. So with the help of explain and your whole query, you can look at the execution plan in the Hive. Similarly, in the pig also, you can look at the execution plan of your code. So I'll just show you. So basically describe your parameter, the data type of the parameter. Uh, explain and illustrate. So let's look at explain and illustrate also. So now if I say ILLUSTRAT illustrate B, so what I did is I have used the same example which I ran previously. I am just using the users file and loading that and giving the data type of that file, and B I am just filtering that not equals to 20. So now if I say illustrate B, it will just get out some sample data from my data set on which B as a variable is dependent on. So here B is dependent on A and A is dependent on this file. So it will just take out some sample data from this file and will illustrate how my output will look for B. So if I say illustrate B, so say it had taken some sample data from A, it had also shown me sample data from A, and as I was doing filtering on 20, the 20 is not there in the B and it's just 32. So this is how my B will look like, and the data type of different columns available in the B. So illustrate is very useful when you are basically writing a pig script and basically doing the debug kind of thing. And describe, B will just do the description. So based on data type defined for A, it has automatically inferred the data type of B. And if I say explain, it will just show you the execution plan. If B need to be dumped or stored, how the execution plan will look like. So this is how the execution plan will look like. So two jobs which will trigger up and how they will trigger up. And you can also look at explain in your Hive also. Any questions? Anything? Am I going too fast or it's making sense?
So what would be the benefit of you knowing how the MapReduce job is going? What would that tell you?
Okay. So
is that just informational or?
No. This is useful to you. I'm just trying to figure out
okay.
How should I explain it to you. Just give me a minute.
Sure.
Okay. Let's say my data is highly skewed. By skewed, I mean to say, say I have to join two files, and one of the files is highly skewed. So let's say I have to join two files. One is the employee table, one is the department table. The employee table is highly skewed on the department. Department ID, which is there in the employee table, is highly random in the corresponding rows. So if there are 5 rows in one by one, the department ID is highly, so if the first row has a department ID 1, the second row has department ID 1000, and so on. Basically, the department ID is the data is highly skewed in my employee table. Now, if I want to do this join, so I'm not going on to those complexities, the map side join, the reduce side join kind of things. So basically what I'm saying is, if the data is highly skewed, I want to do this operation of joining on the reducer side rather than on the map side, because when I'm reading the employee table, I don't have the whole department ID with me, or basically all the department related data. So if I'm somehow able to in the short and simple phase, basically do the sorting of this data and I'm able to reach the data to the reducer part, my job will run fast. Although I'm not giving you a good example right now, but I'm just trying to explain. Basically which scenario you will be looking at. So in such a scenario, you might be trying to use those operators which will be doing your operation on the reduce side. So based on the operation, you can very easily, based on the operators, you can very easily figure out which are the operators which will be running on the reduce side, which are operators which will be running on the mapper side. So say group, order by. These are the operators which will be running on the reducer side. Now you can very easily think of based on the type of the operator. The order by does not make sense to be running on the map side. So pick would be always running it on the reducer side. Similarly, your limit, it will always run on the reduce side. Parallel, parallel will not make sense right now to you. So these are some operators which will be running on the reduce side. So if you look at the plan, you can based on your data, you sometimes very easily optimize your execution flow. But pick those high optimization for you, so you don't have to worry out. But if you're an advanced user and you are using some advanced commands and your program is having hundreds of lines, in that scenario that will make sense, similar to your queries. So when you write your queries, sometimes you look at the execution plan to optimize the queries. Same way it will work for you over here. But that would make sense when you are writing some advanced queries or you are at the advanced phase of the things. So right now I have not even talked about the optimization related things because this is a basic session. So these things are better really make sense for you when you are writing advanced codes. And again,
Okay, so essentially, if by seeing the execution and understanding your data, you may want to change how you have it in your pig code so that it is optimal for the data you have just by looking to see how the map produced code would be generated.
Not only pig code, basically now you can see when you look at this execution plan, and now I know which job is running what. Okay, and now if I go to over here, I can see my first job took 1 minute, second job took 50 seconds, and third job took 50 seconds, and total pig took 3 minutes approximately to run up, right? My first job took 1 minute 31 seconds. But what did first job do? I don't know. But if I look at the execution plan, I know what is first job doing. Now I know this first job had something which is taking high time. Now, if I know the job was taking high time, if I know what this job was doing, I can easily infer which state was taking more time. So to give you one example, so let's say my data was something like this. Okay, let's say I have the same employee table and the department table, and employee table had my data in say file format RC, and this has text. Now if I look at the job one, I am able to, by looking at this UI, I am able to figure out that the job one was taking maximum time in my whole execution, rest all was running in few seconds only. So there was something which need to be changed into job one, what it was doing, and I have to somehow make my whole flow run faster. Now if I look at job one, what was done in the job one was a join. So if now I know the employee was in RC format, but the tech department was text format. So that is the reason my join was taking more time, because this data was not in a column format. So if I change it to RC or ORC, I can reduce the joining time. Or if I look at the data and say this data was in ZZip format, and this data was in say BZZip format. So what was happening up is all of my department data, which was say 5 GBs, was loaded in a single mapper, and that was making this job slow. Now you understand what are different file types, how the different joins look at, or how your data is basically happening at the back end. You can easily look at the execution plan and figure out what could be the problem, why this job is running slow, because you can look at the execution plan. So probably you might not be optimizing the pig code, but mostly you would be doing things like this by looking at the plan. Make sense?
Yeah, I think so. I think with more experience, it makes more sense. But yes, it generally does.
So, so basically, in the first go, you will never be looking at those things. But when your production cluster is ready, and when your manager will say, "Hey, we have 10 node cluster, and what is the fee which you are paying to AWS because is too high because our cluster uptime is too high, and we have to reduce the time, we have to reduce the cost." So in that case, you'll be looking at where the parameter where I can reduce the processing time so that my cluster uptime is less and I'm paying less to Amazon, or I'm paying less to Elasticsearch or whatever cloud which you're using up. Then you will be really looking at or changing the file formats or looking at these things and which job is taking less time, more time, and things like that. So, but you have to understand the system for all these things. So, explain, illustrate all these things which we looked at right now. So for each, I've already told you. So for each is nothing but will run for each row in the file. So there are a few other things for each highlighted in this slide. So I've loaded this NYC daily file which I've just shown you, and these are the few shortcuts for each. So if I say .open, so what does it mean is load all the columns before open column in my data set. So on the columns which are before open are open, exchange, symbol, date. So beginning as a variable will have all the columns exchange, symbol, date, and open, and so basically it produces these columns. Open close will have all the columns between these two columns, and volume will have all the columns after volume including volume. So these are some shortcuts to write this for each. So if I say if my file have 100 columns and I have not even defined the parameter, I can just say $15 to $20. So this will just load these 5 columns and so on. So let's try to run it. So I've just loaded this NYC daily. Now let's look at open. So beginning is the variable name. So if I say now illustrate beginning, so say it will. So this is my prices which I've loaded up. This is all these columns, and beginning has only these columns, and the data type is already inferred for you based on the prices column which I have defined, and it has only these columns and so on. And for each is basically for each row. Filter, the name itself signifies filter the records. So filter the variable and by some symbol. So this is a regular expression. The regular expression is similar to your regular expression used in Java language. So I'll not go into this side, but this is normal regular expression which you use in any other language also. But all I want to show you on the slide is you can use regular expression for filtering. So not is a keyword which you can apply before filter. So this will not. So not matching this regular expression. So if we so I've loaded the dividend file. So dividend file is again similar to your this thing NYC daily file. So here I'm saying is filter this not matching this thing. So if I say, so only all the symbols which are not matching CM, which are not basically starting with CM would be available in this, not starting with CM. So I'm just illustrating it. I'm not dumping it. So see, it has taken two symbols in the sample data. One was with CW, one was CMK. CM is ignored in the in this, and CW is there. Filter group is again it's self-explanatory. Group, I think. So you can group things. So daily is grouped based on a stock. So stock was a variable, so it is grouped. So but there's some complex data types is generated out of groups. So let's look at them. And so what I'm showing right now would make you little bit puzzled, but try to understand that thing. And once you understand that thing, nothing in pig is complex. But just try to understand these things. So this thing and the rest all is very easy in pig. So I've loaded the daily, and okay, so over here now you can see, although the daily has 10 different columns, but I've just loaded 2 columns. So in this case, pig will ignore all other columns while doing a rest processing. So this is again a beauty of dynamic schema. I have just given 2 columns, so pig will just load first 2 columns and will name them as exchange and stock. Rest all columns will be ignored. So if your data is changing up and some data types are added, or some columns are added to your file each day or things like that, pig will all easily ignore that. And this is again a useful case for dynamic schema. So now I say group daily by stock. Okay. Oh, 1 minute. So if you give illustrate and you have not defined the schema, it will give this error like this. So if you are using illustrate, ensure that you have defined the schema, otherwise it will give an error like this. You can use define. So what we'll do is we'll we'll define the data types for them, or we'll use the daily NYC daily, which was there. No, I do not have the schema. Just some file has some schema. I'm just trying to figure out the schema. Give me a minute. No, okay, I'll define it manually. Oops. Okay, so group daily by stocks. So see daily, all of the columns are ignored from that file, only 2 are taken up. And I said group daily by stock, so CI was a stock, so it was grouped. Now you can see it has created bag and tuples for you. So this is the thing which you have to remember up. If you understand this thing, the rest everything is pretty easy in the pig. So there are 2 things which will be created in your group. So group was a variable name. It will always have 1 key that will always be named as group. The key in the group of your statement what I ran is this thing, group daily by stock. So this daily was grouped on stock. So this group will have 2 columns always, where so the group operator will have always 2 columns as an output. The first operator will be your key, and it will always be named as group. And the type of this key would be the type of your of the column on which you have grouped up. So stock was of type char array. So this is also of type char array, and this will be your stock name. And the next thing which will be is a bag, and the type of this bag would always be your type of the operator which is grouped. So bag of type daily, and it will have your tuples of daily. Does this thing make sense to everyone? Or shall I repeat it?
Would you mind repeating it?
Yeah, sure. So what I did is I ran 3 commands. First thing is I loaded a file by the name of daily. So this file is visible over here. 2 columns in the file, rest all are ignored. When I do group on any operator, so I say group daily by stock. So group this daily by stock. Stock is a column in this file. So the group output will always look something like this. It will have 2 columns. The first column will be always named group, and that is a key to the bag. And what is the key is the operator on which I have grouped. So I was grouping on a stock. So this is of type stock, that is char array, and this will contain stocks, different stocks. So it will contain all your unique stocks basically in the final output. And so this is the key of the group, and all the stocks or all the rows in this data which has the stock CII would be available over here. So how they can be made available? They can be made available in a complex data type, and that is of type bag. So what will be the data in the bag? It will be so this will be basically contain the rows, all the rows of this stock. So what would the data type of those rows? That would be definitely the daily. So that will named as a daily, and the type is of a tuple of daily type. So if I have to group this data, say I have okay, and YSC CII CII CY YE CII YE XY and so on. Exchange symbol. So this is your daily I have created on this file. What I said is group daily on stock. So group daily on this thing. So an output would look something like this, CII, and oh, sorry. Oops, I'll type it better. So let's say this was ABC and this was XYZ. So different exchanges basically, NSE exchange, NSE, and this is London Metal Exchange, LME, and so this will have your LME, CII, and your last one is NSC, CII, and so on, right? This is how your data is grouped. So the group would look something like this. So how it can be kept is in a bag, and bag has tuples. Tuples are of type daily. So that's the reason this is named as daily. and this is named as group. So output will be something like this: group and this thing. So this is output. Make sense? And similarly for others, y. So one row for y and one row for your xy, and this will have two things: this thing and this thing, and so on. What is the advantage? Group, normal group operation, what you do in the queries, this will make sense when you're processing your data. A lot of times you'll be doing grouping like we did in the previous statements, in the previous examples. This is a normal group. So how you would keep a group? What is the data type which you will use for group?
Okay, Miraj, let me ask what I want to say. So what I meant is that why would be needing, like grouping we generally do for, summarizing things maybe by getting the maximum of that group or minimum or sum, right?
But before that you
why?
group.
Yeah. So group, I know what it is. But
Yeah.
what I'm saying is that why we want to group the things in this fashion. I mean, where we have this complex type of data type. Because generally we do this. Yeah.
That's what I think. Puneet, you operator you will apply after this. After this step, you will define an operation. So now I say count of different things for each stop. So then I'll apply operators on this thing. But before that, your data need to be grouped. And if your data is grouped, what is the operator or what is the data type which you can use for group? That is bag only, nothing else. So in this example, what is I first group the data on clicks, then only I set, I grouped the data on URL, then only I counted the clicks. First you have to group your data, then only you can do some operation on that, right? Make sense?
Yeah. Okay. So this is a precursor basically. So first that object type has to be created, the complex object type, and then only further summaries or countings has to be done, right?
So if you look at this, so what we did is, oops. Okay. So now, if you look at this, illustrate. So there's that example I'm running over it. So I illustrated this group. I illustrated this one. So that was group on URL. So see, user was loaded. It was filtered based on 20 or what was the age criteria, between 18 to 20 or whatsoever was the age criteria. Then loaded the pages. Then joined both of them. So these are the data again. Okay, I'll tell you this thing also in join. So now this is grouped. So your URL and all the data related to the URL. And the next step, what I want to do is count. Now if I say illustrate sum. So what I did is, now this statement will also make sense for you. For each grouped, generate group. Generate group, that is the URL, generate group, comma, count, joined. And joined is nothing but joined. So this is named as joined, as I told you. Count joined as clicks and name this column as clicked. So if I say illustrate, cannot convert couple to a string. Cannot convert tuple to a string. Cannot convert tuple count join as clicks. What is the problem? I'll look at this later on. So basically, yeah, the output would have looked something like this. So after this, summed, and sum would have two columns. That is your group, that is URL, and the counts 0, 1, 2, 3, 4, things like that. But before that, you have to group the things. So group, we just looked at order by self-explanatory. So order your variable of which you want to order by, and the columns by which you want to order. You want me to run it? I hope it's self-explanatory, right? Distinct, again self-explanatory. So distinct and the operator on which you want to apply distinct. So this will just filter out or the distinct records from this daily. Join, I just shown you joins. So join daily by simple, divs by simple. So these are two operators I have loaded up, daily and divs. So I am joining them by on this. So this is the inner join. If you want to join on more than one column, you can just say by and two columns. So this will join by two columns. So that the data will be inner joined on these two columns. If you want to do some left outer, right outer, so rather than join, you can just say join this by left outer or right outer and based on two columns. If you have to join more than two variables, you can always do that. Join A by X, B by U, C by E. Okay, so before coming to limit, let's try to look at this join also. So I have loaded daily, I have divs. So these are two files, dividend and daily, and I've joined them on symbol. So I have loaded two files, divs and daily, and I've joined them on symbols. So let's look at this joint. I think it will again give not bad. Okay. So this is the first file which I loaded, daily, NYC daily. It has all these variables. I have loaded divs and then I did join them by on symbol. So the output will look something like this. Try to understand this thing also. So it will contain columns from both the files. So it will contain from daily or all the columns from daily. It will contain all the columns of divs also. And how the names will be given to those columns is daily double colon exchange. So all the columns of daily will be prefixed by daily and double colon. So all the columns of daily will come first, and then all the columns of divs. So all the columns of divs, double colon and the column name. So all the columns will come from both the files, and this is how they will be named up in your joined operator. So this is how pig will name them. And the data is, you can see, joined on symbol CI. So we have 2 and 2, 4 combinations. So 4 are, so inner join gave you 4 output, 4 rows. Any questions? Anything which you want to ask? Okay, limit. Limiting the record. So here I am saying only limit 10 rows from this thing. So this is again used for debugging purposes only. Majorly looking at some smaller data sets. Parallel. Okay. So parallel can basically, is similar to your number of reducers. So here I am saying your number of reducers which will be used for this program is 10. So if I say group daily by symbol parallel 10, this will ensure that are the 10 reducers which will be used for this operation. And if 10 reducers are used for this operation, So again, this thing, Sally. So now if I look at some job and I can see that my data, this job is slow, and the data and most of the time is taken by a reducer part. I can think of a number of increasing number of reducers might reduce my job time. So this will again be helpful for you looking at the explain or looking at the job plan and looking at the time which is taking up. So parallel is basically used for only the operators which operate at the reduced side. Based on the operator, you can very easily guess now which is operator which is running at which phase. So definitely the load will be running at mapper side only. Group is running on the reduced side. So a parallel is basically used to define number of reducers which will be used. And if I now dump this B symbol, can anyone tell me how many are the number of files which will be created up if I say dump by symbol? Quick answer for every one of you. How many files will be created? 10. Yes. So 10 files will be created up because 10 reducers will be doing this operation. One file for each reducer. If I want to set the default parallelism for the whole file, so I can just say set this on the top of the file or on the pig console set. So similar to Hive, you can set different parameters in pig also by saying set. So as we did in Hive, set parameter name and the value. Similarly here you can also say set this thing, or you can write on top of the file also this thing. No, mappers, Puneet, this is a question which you should not be asking up. Can you define the number of mappers in the program? Can user define the number of mappers? I need an answer, yes or no. Can user define number of mappers in the execution phase? Don't know, not sure. Don't tell me we will this thing. Number of mappers. It gets the job ID. It figures out number of splits, and based on the splits, what is done? How many are the splits in a program? What is done based on the splits? Number of mappers is equal to number of
splits. So I think number of mappers equal to maybe number of splits.
Yes. And can we define the number of splits in the program? That is dependent on the data.
So split is a logical division of the data.
Yeah. So that is basically dependent on the data which we are processing of. So can you define the number of mappers in the program? The answer is no. That is all dependent on your file.
So Miraj, can we change the size of a split? I think it was 64 MB, right?
That you can do, but you can't define those things. You can't configure those things in your code. You can give hint, but that will always depend on your splits. You can change those things. You can pass a parameter that my split size should be so and so. That will reduce or increase the number of mappers, but you can't physically define like this number of reducers. You can give hints. This is a way to set a hint. Set num.mapper.size. Oh, sorry, num.mapper something like this is there, but that will just a hint. So if you remember, that is also I told you. No, this is advanced MapReduce. This is why I specifically told you in this one of these slides also. This is written somewhere. If you go through them again, you can recall that. So we can't define those things basically. That is written somewhere in this file only, in this bibliography. Okay. Okay, so flatten is reverse of your group. So what group does is the flatten do the reverse of the thing. So this thing will be flatten like this. So let me show you. Okay, we'll come to the YouTube part. So it's okay if we extend for 5-10 more minutes. Is it fine with everyone? Just a few things left in the big part. It will take not more than 10 minutes. Okay. Sure. So it will just extend for 10 more minutes and we will try to wrap up this thing. Okay. So there I have a complex data type. Just a minute. Just give a minute. Where is that? I'll open it. So what I'm doing is I'm just trying to show you some of the complex data types. Although now you are aware of that, but just quickly show you again the thing. So this is a complex data which we will try to load up. That will give you a little bit more clear picture. That is all I want to show. So this is a baseball player's data. The first column is the baseball player name. Second column is the team for which he or she plays. And then we had the positions where he plays. So a user might be playing at more than one positions in the baseball. He might be a catcher also. He might be a designated hitter also. He might be a left fielder or right fielder and so on. So he can basically play at multiple positions. So that thing need to be a type of bag. Then the next is statistics about that player. So number of games he played, number of hits he made, his top runs and so on. So this data is there in the map. So map has the key as your the criteria and the value. And if you remember, maps key and value are separated by hash. So if you have to load this data, we'll load it something like this. So if you have to load this data, what we'll do is, so one minute. So where is this example lying up? I'm just trying to figure that out. Baseball. If you can see somewhere where I'm loading the base wall, that will make my life easier. Otherwise, I have to write the code. Yeah, here it is. So it's in for each. So yeah, here it is. So how I am loading that file, let's look at it. So see, baseball, load that file. First thing, name char array. First thing, name of type char array. Second thing, team of time char array. Third thing, position, that is of type back, and back contains tuple of type char array. Position back, that contains tuple of type cap array, and rest is your map. So I have given the name of the map as bat and of type map, and my data is loaded. Now if I have to do some operation on this data, I have to just refer them. So if I say I have to figure out batting average of each player from this data, so what I did is for each B ball, generate bat. So this is how I get the value of the map. So the map name and the key which for which I want to find the value. So illustrate. So see, from this data it has find batting bat average was 247, so that would be somewhere 247. So this is the only field over there. So this is how you will be loading up if your data is lying like that, but if Pig will dump data like this only for the complex data types. So UDFs as similar to Hive, here also you can create UDFs. So in Java, all you have to do is extend this function eval. This example is there in the code which I have already shared with you, and you have to implement a method called execute. So once you use this UDF, this execute method would be triggered up from your from your program. So what you have to do is you have to register your jar which is created up. So you have to create a jar for this program. You have to register that, and then call the function name. So com.dp.upper is a fully qualified name. So com.dp.upper is the class name. So fully qualified name of that class, and just pass in the parameters. So by default this execute function will be triggered up, and the output of this execute function would be sent as an output to this thing. But again, if you are not acquainted with Java, you can use any other language. So if you have to write in Python, so I have to just write register the Python file, and so JPython is basically used to run Python, and I have to just give the function name, and I'm using that function. So you can create your own UDFs, or you can use the UDFs already there in piggybank.jar. So piggybank.jar would already be there in the class path. You don't have to add that jar in such a scenario. You can just use a function like the way I've used over here. Where's that count gone? So top are the UDF, there was count also somewhere we have used. Count. So this is a function in UDF only. I've used it directly without loading the jar because that is already there in you. If you look at function in piggybank.jar, there is an extensive list of functions. There's extensive list of functions in this piggybank, and you can use them. So that is already there in a class path. You don't have to worry about that. Comes with pig. So there's extensive list of functions. You can look at them. There's a lot of functions. There's a list of functions. It's going a little slow, but you can browse them. There's an extensive list of functions related to date, char, int, and all those things. So that's all from the pig part. Any questions? I'll share you a problem statement. Try to run that. Today we don't have time. If you want to run it in the next class, you can run it, or you can try it at your end and basically run it. Any questions which you have? Anything which you want to ask? Agenda for tomorrow. Okay. So tomorrow we have not yet looked at the yarn part. I will look at the yarn, and then let's look at scoop, and if time persists, let's look at Uzi also. Okay, sure then, everyone. Thanks for your time. Let's meet tomorrow at the same time, and have a nice day.